Hello, I'm Dr. Harper. This video is an operations management. It's a lecture video on quality. So let's bring up the notes. Now, operations management quality control, this is just an introduction to the concepts and a little bit on mechanics. There's a lot more than this, so you probably should have a whole course just on quality control. But this is just an introduction to give you some concepts, definitions, and a little bit on the mechanics. So quality program can be broken up into three stages: quality planning, quality assurance, sometimes referred to as QA, quality control, and sometimes referred to as QC. Under quality planning, this is everything done before you start measuring quality. Define what quality is, set your quality standards, and the output is create a quality plan. Now in operations, the process control charts will be applied. And you'll build the control charts, you'll design what you're measuring, how you're measuring it, or acceptance sampling. Now in this course we will not be doing acceptance sampling, but I will be introducing and discussing very briefly process control charts. But then quality assurance is implementing the quality plan. And implementing the plan, here's where you measure, here's where you observe, here's where you report. You'll have quality reports in your operations, and even quality audits in your operation. And the audits could audit the process of quality assurance. And audit simply means looking at to make sure everything is done correctly, as far as measuring correctly, reporting correctly, but also everything was designed correctly. Okay, and then quality control. Quality control is where you monitor the plan and improve quality. Here's where you have change management. And here's where you have something called the method of assignable cause. In other words, in quality assurance, and this is the way I'm dividing it up, other people will divide this differently. The way I'm dividing this up is quality assurance is implementing a plan, measuring it, identifying changes that need to be made. Quality control is actually making a decision: do we make the plan, or do we not make the plan, make the changes? And if we make the changes, how do we do it? And change management includes something called configuration management. If you make a change, sometimes that change requires changes other places in the process. So you have change management and also configuring that change within the process. And sometimes you have to change other things so that change becomes effective. And also that includes another technique called the method of assignable cause, where when you have a change that's needed, in order to make that change, then you have to go back to find the cause of some anomaly or what's going to make that change. In other words, you got to be careful you don't make a change where you see the change. You make a change where the change was caused. And you look at the cause of the change. And then you change that, assign the cause to something you observe, and then you change. So these three stages within a quality control program is important to do. And each one's different. Here's your planning. You might have statistical engineers. You have quality assurance, where you have the process engineers. And here you have quality control, where you have design engineers. And so these are three different operations going on. Okay, but in this video, I'm going to focus on process control charts, implementing those charts, and then later in another video, I will talk about the control using the charts. So here's the statistical quality control area, can be broken up into two different main branches. Statistical process control, which we'll look at in this video, and acceptance sampling, which we will not look at in this video. That would be in another video and in another development. Okay, process control charts is based on the statistical theory of confidence intervals. Acceptance sampling is based on the statistical theory of test of hypothesis. So this is truly a statistical quality control. Both of these are techniques from three different approaches and three different statistical concepts. In turn, they're broken up on how the quality characteristic is being measured, either variables, which are continuous, or attributes, discrete measurements. Likewise for acceptance sampling, variable sampling plans, and attribute or discrete sampling plans. Well, here's the concept, quality concept. Suppose you have a process, and this could be a manufacturing process or a service process, but you're outputting a product. So the product could be a product, or the product could be a satisfied customer. But in that product, you'll have a number of quality characteristics you could measure. A lot of them. You can measure the appearance, you can measure the performance, you can measure the dimensions, you can measure the power, or you can measure a satisfied customer, or was the price right for the customer? Was the service right for the customer? Was the order right for the customer? So there's a lot of things you can measure. Well, in process control charts, or in process quality control, the quality concept is you identify one of those characteristics at a time. And from that, you draw a sample of size n from the products being produced. Now that sample of size n, you analyze it. And that sample, there's different ways of analyzing it, and there's where the process control charts come in, and there's where acceptance sampling comes in. But you analyze that sample, and that sample could indicate good quality or bad quality. And let's suppose it's good quality. No problem. Then go ahead and let it go to the customer. Let the customer continue on. But what if that sample illustrates bad quality? Something that has to be addressed. There's two approaches. The first approach is acceptance sampling. Compare the quality characteristic from the sample, whatever the result is up here, compare it with an acceptance number or a rejection number, and make a decision about a lot. Now the lot is the group. Usually you're taking a sample from a large number of measurements, or you're taking a sample over time. Or the time would be the lot. And so you make a decision. And so you have an acceptance and rejection number. If it's in the acceptance area, fine. If it's in the rejection area, then you're going to reject it. But if you reject it, then that leads to a decision. When you reject it, what do you do? If it's a product, do you discard it? If it's a product, do you re-engineer it? Do you repair it? Do you remanufacture it? Do you send it to a secondary market? What do you do? And so that's a whole different topic, and that's not going to be covered in this course or in this lecture. That is for another lecture and another course. What we will cover is the statistical process control. Okay, and so acceptance sampling says, I'm going to evaluate this sample. It's bad quality. I'm not going to let the customer have it and reject it. Process control is a little different approach. It examines a quality characteristic from a sample on the process control chart and makes an inference about the control of the process. In other words, it'll look at a chart and it goes back to the process and makes an inference about the process. Is this process in control? Now, if it's bad quality, then you'll infer, and notice I'm saying not making a decision, you're inferring that the process, you infer the control of the process, whether it's in control, out of control, or it's in control, the levels of out of control. But then that goes to control, the control branch of your quality program, and make a decision. Should we change it? What should we do? And then you go into method of assignable cause. Okay, so what we're doing here is saying, okay, with the statistical process control, think about this. You're saying, I have output, and this output I can measure, and that measurement can say either this is good or bad. If it starts getting bad, what do I do? Now I have to make sure that what I'm generating is good, and if it's questionable or bad or questionable, then I have to change to say, I have to do something about this. What do I do? Well, what we're looking at is how you measure this and decide whether you should make a change or not. I'm not going to talk about what the change should be because it depends on the actual application. Now, acceptance sampling usually is with very large organizations, big organizations like the government, but statistical process control can be done on big organizations, small organizations. Process control charts can also be done with individuals. You can monitor your own output over time just for your own assurance and your own control of what you're doing. And that's why I'm covering it at this level, something really simple. So how would we construct a chart? So let's look at how to construct a very simple process control chart. Now there's all different ways of constructing a chart. All I'm doing is introducing a concept, more of a concept. You can use this if you have this kind of data. But applying a chart, you got to be careful, say, is this the right kind of data? Is this the right kind of variable or quality characteristic? Is this the right kind of approach? So let's go through this. And that's what I mean by for instructional purposes. So this is not necessarily practical across the board. In rare cases, this could be used as I'm giving it to you. But usually there's something more sophisticated, and that gets into a statistical process control lecture and course. Assume the random sample from an experiment is 3, 4, 4, 5, 5, 5, 6, 8. I rank ordered it. The sample size is 8 because there's 8 numbers. The sample's mean is 5 because I'm going to sum. I sum the numbers and divide by 8. I got 5. And the sample variance is 2. So I sum the difference about the mean, square it, divide by n, and that's going to be 2. And notice I'm dividing by n. I'm calling it a sample variance, but in quality control I divide by n, not n minus 1, for those of you who've had statistics. So note, that's why I gave the equation, because we're doing this in statistical process control. So that's how we're defining it. And that's not how it's defined in statistics, by the way. A sample variance will be n minus 1, but we're not doing that in process control and quality control. Okay, construct a process control chart. Well, the definition is this, right here. The mean, which is going to be 5, plus or minus 3 times the standard deviation of the mean. Okay, let's do it. Control chart is there's the definition. The mean plus or minus 3 times the standard deviation of the mean. Now that 3 there is standard. Now some companies, some applications will change the 3 to a 2 to a 4, but 3 has been standard, which is equivalent to the mean plus or minus 3. Now the standard deviation of the mean is the square root of the variance of the mean by definition. Okay, because the standard deviation equals the square root of the variance, which is equivalent to 3 times the square root of the variance over n, because the variance of the mean is the variance of a random variable divided by n. Notice this variance here is the variance from the sample, which is the variance of a random variable of that sample. It's not the variance of the mean of the sample, it's a variance of the sample of a single variable x in that sample. So it's a variable, it's the variance of x. It's not the variance of the mean of x. So the variance of the mean, so the variance of x is given to be this. The variance of the mean is going to be this variance up here divided by n. Well, the variance is 2. Divided by n. The variance is 2, and the sample size is 8, so it's 2 over 8. Okay, so substitute the values. Sample size, n equals 8. Mean, 5. Variance is 2. I just copied that down. The mean here, plus or minus 3 times the square root of the variance of n, I bring this down. So let's do it. Let's plug and crank. The mean is 5. I bring 5 down. Plus or minus 3, that's standard. The square root of the variance, which is 2, I bring that down. Over n is 8, bring that down. Well, 2 over 8 is 1/4. The square root of 1/4 is 1/2 times 3 is 5 plus or minus 3 halves. Therefore, the process control chart becomes the center line is 5. The upper control limit is 5 plus the 1.5, which is 6.5. The lower control limit is 5 minus 1.5, which is 3.5. So the quality characteristic then in production will be measured and plotted on a process control chart, this process control chart, to control the process, to make inferences about is it in control, is it out of control. That's the quality assurance. It'll move to quality control if you're inferring that it could be out of control. And so there's the chart. So here we have upper control limit, lower control limit, center line. And so over time, you measure output of a quality characteristic. And the quality characteristic you're measuring is the process that generated these numbers up here, because this chart came from those numbers. The same variable that generated the numbers is plotted on the chart. They have to be the same. And so not the same numbers, but the same process. And so you plot it, bing, 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 bing. And if all the things in here, let's go ahead and insert this shape, this right here. So if we do this, boom, 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 all along, if it's in here, you're fine. If all of a sudden it's outside, then all of a sudden that's a problem. Boom, that right there is going to be a problem. Right here, this is a problem. And we're going to have format, shape, fill, no fill. So that's going to be a problem up here because it's greater than, it could be greater than it's a problem, lower than it's a problem. There's where the inference comes in. You've identified there's a problem. Okay? Okay. Now, as I say, this is just an introduction. Actually, there's a lot of different control charts out there. There's dozens of them. A course, an introductory course in statistical process control would probably cover these four charts. The P chart, which measures the proportion. See, this is just measuring one observation. One observation. Well, you can have a P chart, which is a control chart on the proportion of an attribute characteristic. The C chart is the counter frequency of an attribute characteristic. The M chart is a mean of a variable characteristic, and the range is the range of a variable characteristic from a sample. Here are four of the common process control charts that are introduced initially. These are not the only four. There are many of them. The concept, though, the basic concept, even though this process is so simple that it's rarely used, but it's good to illustrate what it does. And so each one of these steps then will be broadened and going deeper in a course or a treatment or a lecture. And I do have lectures on some of these. But that's all I have for the quality control. Just to give a good introduction on what quality program and quality control is in operations, because quality now is part of pretty much every operation. Make sure it's done in a quality. Well, when you have products or services that have measurements, how do you handle the measurements? You don't just look at them. Well, there's a way to actually monitor them to make inferences about the control of the process that generated them. And that's what this is about. So that's all I have for today on quality. I hope this helps. And between now and the next time I see you, take care.